Welcome back to Math 107 College Algebra. In this video, we're going to take a look at solving a system of equations by Cramer's rule. And I'm going to show this in the case of a 2x2, or system of two equations and two variables. This can be expanded to any number of variables or equations with the same number of variables as equations. So I will use the system x plus 2y equals 3, and 4x plus 5y equals 6. And we're going to actually use three different matrices here, and we're going to take what's called the determinant. So the determinant of a 2x2 matrix, and we're going to use vertical bars around the matrix to indicate that we're taking the determinant. I'm going to draw some lines in here. So we're going to multiply along the diagonals. Diagonals going down and to the right, we're going to add. So AD. And we're going to subtract the diagonals going up and to the left. So AD minus BC. So that's how we take the determinant. So we're going to take three different determinants. The determinant D is going to be the determinant of the coefficients. So that'll be 1, 2, 4, 5. I take that determinant, that's going to be 5 minus 8, which is negative 3. And then I'm going to do two more. D sub x. I'm going to replace the coefficients on x with the constants, so that will make the matrix 3, 6, 2, 5. So the determinant's now going to be 3 times 5 is 15, minus 2 times 6 is 12. So that's 3. And d sub y is going to be the similar idea. I'm going to take the original coefficient matrix and replace the coefficients on y with the constants. So that'll be 1 times 6 is 6, minus 3 times 4 is 12. So that equals negative 6. So now we have d equals negative 3. D sub x is equal to 3. And d sub y is equal to negative 6. And then the final solutions to our equation, or final solution to our system of equations is going to be x equals d sub x over d. So that's negative, I'm sorry, 3 over negative 3, which is a negative 1. And y is going to equal d sub y over d, which is negative 6 over negative 3, or 2. So I write the solution to our system of equations as negative 1, 2. And like I said, we can do that with a 3x3 matrix. I'm not going to take the time to actually teach how to find the determinant of a 3x3 matrix, but it would be the same idea. And you can take the determinant of any matrix, well, any square matrix, because the determinant is not defined in matrices that aren't square, by entering the matrix as we did today in class into the calculator, and just using the DET command. So, that will conclude this video. In class, we'll talk a little bit more about Cramer's rule and how it can break down sometimes. And then we'll talk at the end of the course about how to solve systems of equations that aren't linear. So I will see you in class on Thursday.